My name is Artem Prashkovich, and today I will talk about the possible options to deploy our Sitecore environments, and especially to the Azure architecture. So we will talk about the Kubernetes, because the Kubernetes underlie the Sitecore Managed Cloud, and it's probably impossible to explain what is the Sitecore Managed Cloud, how it works without understanding how Kubernetes works. Also, we will talk a bit about the GitOps definition, and I will explain what is it and how it is actually used with Managed Cloud. So, and here I want to say a few words about me. So, I have more than 11 years of programming experience. I have, so since April 2012, I work for Brimit, and more than 10 years I have an experience of so sorry, I forgot to turn on my camera. Yeah. I have more than 10 years experience in Sitecore, and actually I was awarded as Sitecore MVP for 5 times already. So from this point we can switch to the next slide, which represent the dependency from flexibility to velocity, and from the left side we have maximum flexibility, and from the right side we have maximum velocity. So let's say in the black boxes we have something which is our provider is responsible for, and in the gray boxes we have something that user responsible for. And if we will look at the on the first option, which we can use to deploy our Sitecore instances, which is on-premise environments. This is something which we host ourselves. We are responsible for everything. So we install servers, we install storage, network, set up networking, and everything else, including the application itself. So next all options are represent the Azure technologies, and the first option that available for us to deploy our Sitecore instance is IaaS environment. This is infrastructure as a service. So we can consider that as a virtual machine that Azure provides for us, and we can deploy our solution and our applications there. So next two options is containerized approach. I will call it like a CAS. This is containers as a services, and PaaS, platform as a services. So for the platform as a services, user responsible for the application only, and the provider is support everything else. So it even the infrastructure, operation system, and some runtime thread. For the containers, in terms of Azure provides us the Kubernetes cluster, and we deploy our application there. So with latest news, Sitecore can be also run in SaaS platform, which is service as a service. So this is kind of new technology that we still not try, but I think we will get on this experience soon, and of course we'll discover this option as well. Let's take a look a bit detail in the options that we have to deploy our Sitecore instance to Azure. And if we will talk about the infrastructure as a service, we have some advantages and disadvantages, of course. And having IaaS organization don't need to worry about maintaining hardware and network equipment. They don't need to ensure uptime and replacing old equipment, actually. So having a third-party service that manage your infrastructure can save your organization a lot of money, for sure. So another advantage is that we don't the organization don't need to upgrade software and hardware or even troubleshoot any equipment problems, and infrastructure and hardware can be scaled up and down that quickly in response to the company requirements. As well as scalability, IIS offers strong reliability, allowing you to configure an architecture that can survive even a specific part of your solution would fail or experience any outage. From other side, we have some disadvantages, and first of all, the enterprise that does not have any control over the cloud security in IIS environment. So everything which is outside of your virtual machine is under the responsibility of provider, and you cannot affect any networking settings and something like that. Also, software platforms are often updated or changed without warning, which can sometimes be sometimes problematic, as well as you may not receive critical updates in time if something goes wrong. Also, organizations or enterprise can face some downtime with IIS during maintenance or patching, and it will restrict their access to the application and its data. And having IIS in your organization means that there is a direct dependency on the provider or third party for your data management and maintenance. And compared with PaaS, we also have some advantages and disadvantages, of course. And first of all, when we use in a PaaS system, a real saving are possible since you don't need to perform low-level work yourself, and you don't have to hire additional engineers or pay for extra working hours. So all maintenance will be done by a provider or Azure in our case. PaaS experts continuously perform all the necessary component upgrades and security patches for you, and you get it automatically. You don't need to think about it. And scalability of PaaS is provided by default due to configurable or automated scaling mechanisms. So now about a few words about the disadvantages, and from on the one hand, it is a great advantage that a certain part of work is done by the provider rather than your IT team. On the other hand, your business will still be governed by the provider's functional capabilities and its speed and reliability. And if we have some advantage to reduce our costs, of course, we have some disadvantage that can provide potentially make this cost is higher, and especially that is related to the Sitecore. For example, for Sitecore XP topology, we have a lot of roles that we have to run within our environment and our PaaS. And the PaaS represent the separate apps, web apps for each Sitecore role, especially for the Xconnect and all automations and analytics service that we have in Sitecore XP. It will be run in separate web apps, which means that we have to allocate resources for each of them. And comparing it with IIS, for example, where we can group some roles in the same virtual machine and like share resources of this machine between different services, between different roles. And now we can switch to the Kubernetes or containerized approach. And of course, probably the main advantage of containers is the scalability. Kubernetes can scale the application and underlying infrastructure resources up and down uh, based on your application needs. So, for example, you run some marketing campaign in which where you expect more traffic on your site. So then, in that time, when Kubernetes will identify that your website has require more resources, it will be scaled up automatically, and the resources, and you will pay, of course, for that, for those extra resources. But once the campaign is done, is finished, or probably the business hours uh, finished, so and those resources will be automatically uh, scaled down. So, and you will not pay for those CPU resources or for memory and etc. So another advantage of Kubernetes is powerful CI/CD processes. So especially Kubernetes supports out of the box a kind of blue-green deployment when you have zero downtime on your deployments. So when every time when you deliver something new, so new version of your application in Kubernetes cluster, new copy of your application will be created and run. And once Kubernetes will make sure that your application works and healthy, the traffic will be switched to the new instance of your application, and old instance will be shut down and terminated. So also it supports and provides a really flexible mechanism of rollbacks. So you can always back to the previous images, and even you can switch very fast, and so you can run new instance nearby with the previous images, so you're very flexible in terms of your deployments. So if some of the containers goes down due to hardware or software fault, the Kubernetes system ensures that it is replaced in due time. So you also make sure that you have some kind of high availability. So network encryption is one of the advantages. So Kubernetes utilizes TLS to encrypt network traffic inside and outside the host network. So again, cost optimization, and this is related maybe with the first advantage, which is scalability, because in AKS you pay only for resources that were used, and resources allocation is automatically modulated to the actual application needs. So again, you don't use resources, you don't pay for them. So you have like a lot of traffic on your site, you pay for the resources, but again, once evening is gone, you can probably pay less for that. So from other side, Kubernetes requires experience and extensive training for its debugging and troubleshooting. And this is kind of disadvantage, because finally it can become as a complexity, and the complexity can always converts to the costs. And as I said, Kubernetes is difficult to learn, which means that you will waste of a lot of time if your team encounters any difficulties while implementing and configuration, while implementation and configuration, which will in turn bring a higher cost finally. This is something which I experienced on myself. So because when we was run the first environment in Kubernetes, everything was very unclear, difficult. We spent a lot of time just to investigate how it works, why it doesn't work. Even it was unclear how we can read logs from some Sitecore roles. And for the first instance, it took a lot of time it took a lot of time just to get it run and up and run. So, but with getting more and more experience, it becomes more clear and faster. So, but we have to think about it when we run and agree to run something in Kubernetes. Now, I want to say a few words about the general approach in terms of deployments to the on-premise, IaaS, or even to the PaaS. All of them are deployed in the similar way. So, of course, the details on this diagram can be different from each system to another, but the main idea is kind of looks like on the diagram. So we have a developer who push code to the repository. We have some code analysis and probably tests running on our Git repository, so which is usually happen in ideal world, so that's not always happen, I think. So then we have build pipelines, which represent our continuous integration process. And the build can be run automatically, it can be run manually by some trigger from the Git repository. So on push, on pull request merge, so a lot of options. And once our build is run, we perform uh, again some testing in our ideal world. So we actually build the application. So it depends which application you build. So it can be .NET, it can be JavaScript, doesn't matter. So you have to build your application, and as a result of this build, we have artifacts that we have to push to the artifact storage. And our last point of our continuous integration process is the artifact storage. It can be hosted in Azure, it can be hosted somewhere else. So it even can be just, it should store some packages. So once we have artifacts ready, we have to deploy them to the server, let's say. And here, the place where our continuous deployment starts its work. And we have release pipelines, which also can be run automatically or manually. It depends your requirements and business logic. So, and when we run our deployment, we test something again. Oops, sorry. And once all tests are passed, we make sure that we can deploy it. And finally, our changes becomes to the server on the Azure on-premise, IaaS, web apps, doesn't matter. So actually our code is deployed. So this is how it looks for most original ways to deploy our applications. And now I would like to explain how to deployments happens for the Kubernetes. But before I will switch to the similar diagram for Kubernetes, I want to explain something that will make sure to that will make it easy to understand how it actually works. So, and this diagram this is high level diagram which represent the Kubernetes instance. So we have, of course, on top of that we have Azure, but that can be anything else. So there can be Amazon, that can be Google Cloud, so anything which supports the Kubernetes. Inside of Azure, we have resource group, which is pretty common for each environment. And inside of the resource group, we create the EKS cluster. So inside of the Kubernetes, inside of the cluster, we always have the master node. So we can understand node as a kind of virtual machine. So that's not a virtual machine. So that's completely not. But to make it more understandable, so we can call it like a virtual machine. So because we allocate inside of the Kubernetes, we allocate the resources for the node. So if we say that we want to have 8 CPU cores, this previous 8 cores, and 30 gigabytes of memory, for example. For our Kubernetes instance, we will allocate these resources for the node. Inside of node, we run our application. So, as I said, Kubernetes has always at least one node which is master and which is represent only Linux node. We usually don't run anything on this node, but it is also possible. We can just use these resources allocated for this node for our small applications, for example. But this is like a system node used by Kubernetes itself. It stores the history, state, and everything else on this node. So to run Sitecore in Kubernetes, we have to use Windows node, which is sometimes provides some difficulties in terms of company requirements. Not company allowed to use Windows nodes within their applications. I don't know. So it seems like something related to the security policies, but that was primarily for the financial company with very strong security restrictions, and it seems like it doesn't have something that was required for them. But anyway, we have to use Windows node, and because our Sitecore application is based on the .NET, even it is still not .NET Core, which can be run within Linux. And inside of the node, we have pods. So each icon and each role actually, which we can see inside of the node, is represent the pod, and pod is the smallest deliverable item in terms of Kubernetes. So actually, this is a result of execution of deployment. This is a result of execution of job, and everything what we do with Kubernetes and cluster will become as a pod actually. Each pods inside of the Kubernetes can communicate with each other without any additional configuration. They work as they can communicate it out of the box, but sometimes this communication can be denied. So, and then we have to specify which pod can communicate with which pod. So yeah, we can define the roles that will and the pods that will be available for some of them. And finally, if you want to access some pods from outside, we have to use ingress controller, and especially with the Sitecore, we usually use Nginx ingress controller, and that kind of, we can understand it as a proxy server. All request which goes from the outside of the cluster will be handled by the ingress controller, and based on some rules that usually based on some host names mapping, the request will be redirected and route to the corresponding pod. So if, for example, we place in the browser the host name like cm.test.com, and we for sure should want to be redirected to the CM, and this ingress control will play this role to route us to the according pods. So also we can see that we have a SQL Server and Elastic Pool running in our Azure instance, and we have Redis and Search stacks running as third-party services as well. So Redis can be run inside of the Azure for sure. But this is setup is primarily recommended for the production instances. Within the non-production instances like test server, QA, or even acceptance, we can run Redis and Solr inside of the Kubernetes, as well as the SQL Server. You probably don't want to pay for the license for the SQL, and you can run it inside of the Kubernetes, and that will work for non-production instances. So, which will make something cheaper, but at the same time, it will require more resources, and the node size that required only for the Sitecore will be not enough to run everything inside of this node. So we will have to scale it up a bit, and we will again pay more, but maybe it will be less than pay to for Sitecore SQL Server separately. Oh, Azure SQL Server separately. Sorry. And when we goes next to the next slide, we can see the list of files that I actually want to show you in the file system. Yeah, so let's say you decided to deploy your Sitecore instance to the Kubernetes. And what you actually do, you just go to the Sitecore site, find your Sitecore version that you want to install, and download the package for containerized deployments, which will include the list of folders for XM, for XP topology. It just describes more roles, and I would like to look at the simple way, simplest, more simple view of the deployment and definition. So, and all these files actually in folders represent the specification for our Kubernetes instances. So all of them will be run separately. So we don't have one command that will execute everything and deploy all our application to the Kubernetes. So we have to go. So mainly we have the documentation provided by Sitecore that I highly recommend it to read before you will decide to deploy something to the Kubernetes, because that will at least explain the steps and order of steps that you have to proceed to deploy something to Kubernetes. And actually, you will go through folder to folder and run the corresponding commands to add some required stuff to the Kubernetes before you will run Sitecore itself. For example, we have the external folder which include SQL Server, Redis, and Solar, and this external services will be run within non-production, can be run within non-production instances. And of course, if you want, you have to go to this folder, go to the PowerShell and execute command that will add those services to the Kubernetes cluster. We have ingress definition here. Let's probably have a quickly look at the files that we have here. It is loading. Just a second. Okay. So this is the, maybe it makes sense to zoom in. That represent the default configuration for our ingress controller. As I was said on the previous diagram, we have some rules, which is here, that say us if hostname will, this is the variable, so that can be actually anything. But if host is, let's say, cd hostname, our request should be redirected to the service, which is pod finally, with name cd. And the same for the CM and the ID. So this is how actually we configure our ingress controller. We have init images. This is important part of the deployment, because we have to run init images before we run Sitecore itself. That's impossible to do in another order. So, and the SQL MS SQL init image, not image, so this is an YAML file which represent finally the image, will be executed, and within this image we will got the databases created inside of our SQL server within the content that provides with the Sitecore out of the box. So it will initiate our databases, and Solar init will initiate our indexes that Sitecore require. If you want to add something to the our database, or you probably require additional indexes created within the Kubernetes, you have to create a custom images on top of the images provided by Sitecore. So this is like default Sitecore image that we have to use as a base image for our custom, and we will add our additional cores to this image. And then when this image will be installed to our Kubernetes instances, we will have a full list of indexes created initially. So we don't actually have to create any indexes manually, as well as we don't need to install any custom packages like GSS, SXA. All of these packages can be included to the database already on the initiation stage. And this is a recommended way how we should do that. So then one more important folder, which is secrets. All secrets are stored as files. Then we just upload these secrets to our Kubernetes instances, and we use them as a key vault. So we key value pairs. So, but the main idea and probably my recommendation is to use some key vaults to store the secrets, and this is fine for non-production environments when we just keep everything on file system. But for the production, we have execute some more secureable way to store our sensitive information. At least we can just place some tokens here and replace them within our CI/CD pipelines. That will be even better than just store values inside of the text files here. And finally, we have 3 roles running within the XM. Each of them, if we will open, we will see that this is some specification for our CD server, and that has some custom syntaxes for Kubernetes. And actually, we just specify some environment variables here. We specify some health checks, URLs and requests that will be executed when this image will be run in Kubernetes. We specify some resources requirements which will not allow us to run, for example, CD server once I have opened it within the Kubernetes if we will have less than 500 megabytes of memory, for example, available within our Kubernetes instance. So then when Kubernetes will see that we don't have enough memory, Kubernetes will try to scale up the node if it's possible, and once it will be scaled up, this image will be run. Sometimes it is just required when you deploy new instance of your application. For example, we deploy CD server, and first of all, Kubernetes tried to create a new instance, and the old instance still works. And then in this time, we have 2 CD server running in the same time. So, and if you have resources only for your running instance with deployment, you can get the situation when you don't have enough resources to run new build, and so to run new instance, and your deployment will probably fail. So if you don't have any configuration that will allow you to scale up the node and allocate new resources to get it run. But once deployment will happen, old CD server will be terminated, your resources will be scaled down again. And for the CM server, we have only 3 roles required. And customization file is always replace something which is defined in the YAML files itself. For example, if you will look at again to the CD server, we can see that we have image which is called just Sitecore XM1 CD, which is not actually the image path. And if it will be actually replaced within the customization files, and we define that Sitecore XM1 CD should be replaced within this image. It is used to make upgrades easy. So you don't change the original files. So even you need to make some changes on side of the CD, for example, CD server, we will create override folder here and create additional file, CD file, and just replace existing changes. But we will not. It is better. It is best practice to don't change CD, to don't change the root specification files to make further upgrades and setup easier. So this is about the file system. And this diagram represents the list of commands that we have to execute to run our Sitecore instance. This is very simplified version. So this is just the command that I got from the Sitecore documentation, and just want to provide an example how it looks. And first of all, we create an EKS cluster. Then we have to connect to this cluster. Just so everything happens inside of the PowerShell. We don't do anything directly to the with Azure portal. We just locally use our PowerShell, connect actually with the second command to our cluster, and then we perform the actions. Perform the actions within our file system with the files that we was shown in the previous slide. And for example, we apply the ingress nginx configuration, then we apply the secrets to our apply actually means that we upload it to the Kubernetes cluster. So after the secrets, we run external services, and there is something that also makes sense to mention, that if you will go to will do that according to the documentation provided by Sitecore, you will try to execute and add external services before secrets, but it will not work because some of the external services require some secrets already available, and that then you will probably spend some time just trying to understand why it doesn't work, but actually you just need to swap the order of executions. So once we have secrets and external services running, because next step we will try to initiate our Solr and SQL databases, so which means of course we have to have those services available. And once we initiate indexes and databases, we add some persistent volume storages. The volume storages are persistent volume storages are used for storing the logs, and I probably prefer to store the indexes there if you are going to use uh, the Solr as for the non-production server for UAT, for example, and still want to have it like a stable. I would like to recommend to store indexes inside of the persistent storage. Then even your cluster or Solr pod will be restart. You will not lose your data. You will still able to use your indexes and data inside of these indexes. Otherwise, you will have to reinitiate them and rebuild your indexes. The same for the databases. And finally, we just deploy our pods, Sitecore pods, and which represent Sitecore roles. Next thing that I want to explain, it is base images. When I was starting working with the Docker and Kubernetes, probably Docker especially, I was very often mentioning that I have to create something on top of the base images. But what is the base images? How to create something on top of these images? That was not explained. But yeah, for me it was kind of unclear, and I spent a lot of time just trying to understand what is it. But finally, in terms of Docker world, so we have base image. Base image is always the operation system. It can be Linux based or Windows based, and for the Windows based containers, we have to use one of the 4 base images provided by Microsoft. Of course, I just think that there is some community images also exist, but I haven't tried to use them. But from the official base images for Windows, we have 4, and The smaller one is a Windows Server Core that can be used to run. So this is not smallest, sorry. This is the most usable that we use to run even Sitecore. It is image that allow us to run the traditional .NET frameworks, and we have Nano server, which is a very light version, and it allows us to run .NET Core applications. And so then we have two bigger versions, which will represent the full version of Windows, which is not required and no makes sense. Even the base image that used by Sitecore, Windows Server Core, it takes like 9 gigabytes of memory, so that's the minimum size of the image at least. So once we decided that we want to build our image based on the Windows Server Core, it will underlie all our custom image. And then, for example, we want to build the Sitecore build its base image, uh, base image on top of the base image. But anyway, so what Sitecore actually do? Sitecore add web root files to the c/www in that pub roots folder. It adds some scripts to create and run IIS sites, and also apply some and install some dev tools required for example, for running transformation and config transformations, other dev tools, dev dev steps and tasks. So, and then when we have to build something on top of the Sitecore base image, we create a new image which will be based on the Sitecore's one. And in this case, we just add additional project-related DLLs binaries inside of the web root folder created and added by Sitecore. Of course, we apply some customizations and add some custom configs there. So we can also write something inside of the Sitecore folder. So actually, we work with the root folder. So once we will open the Windows base image, we will see inside we always have drive C, and inside of this folder we will see that we have like 4 folders and 1 file. Then if we will already look to the C drive of Sitecore image that we actually usually use as a base for our custom images, we will see that Sitecore already added a lot of stuff here. There is inetpub folder with your application root. There is some dev tools, which is just called tools, transforms, and the rest of the stuff required to run your IIS application. For example, there is a script which will run web services. And finally, if we will look at the folder in that pub www root, you will see that there is a pretty standard Sitecore application that we see when we was previously download our on-premise package, the installation packages for on-premise. So if we will unzip them, we will see the same files there. So this is how containers looks inside. So this just a representation of the operation system with pre-installed the Sitecore or any other application. So, and now this is a time when we can switch to the actually deployments for Kubernetes. Originally, it looks pretty similar, and especially on the left side is definitely similar. We still have definitely the same even. So we have a developer who push the code to the repository, code analysis, and then we perform the build and run the build pipelines. And the build pipeline will already be executed in a bit different way. So it will use the Docker tool to build our custom image. And once the build will be executed, the Sitecore base images will be downloaded from the Sitecore from the Sitecore container registry. Container registry actually this is a storage for our this is a storage for our image images. So Sitecore, once we have it built, we push our custom images to the Azure Container Registry. Also, it can be any other different container registries, but this is like in case of our standard deployments, it is represent the storage for our container images that we will further execute and run on our Kubernetes. So when image is pushed, we run the deployment, and which is the release pipeline, and that will actually ask our Kubernetes to pull latest images. So we will not even push something from the pipelines to the Kubernetes. We just send the command that, for example, CM image should pull new image from the content registry, and the Kubernetes will try to Kubernetes will check if this actually new version exists, and if it actually exists, it will pull it and run. So this is how deployments looks for the Kubernetes. And now the time when I want to explain the definition of GitOps. And GitOps is not like a tool. This is a paradigm or set of practices that takes DevOps best practices used for the application developments, such as version control, collaboration, compliance, and CI/CD tooling, and apply them to the infrastructure automation. Also, GitOps is used to automate the process of provisioning infrastructure. In the same time, GitOps is the representation of infrastructure as a code. This is when our infrastructure definition are placed in some repository, and if you want to deploy something new in our infrastructure, we don't make these changes manually inside of the, for example, Azure portal. We just change the code, the JSON files or YAML files that are stored in the repository, and the result of these changes will be executed on our Azure, and we will get these changes on our portal and our infrastructure. And GitHub configuration files generate the same infrastructure. So this is important part. This is probably the main idea to use GitOps. That is, GitOps generate the same infrastructure environment every time it is deployed, just as application source code generate the same application binaries every time when it's built. So we can we can be sure that when we deploy our environment within the same code, we will have always the same environments as a result. So which means that we can shut down something and get it run back from our code again, and we have got the working infrastructure every time when we deploy it. So, and there is two tools that is used to reach to implement our GitOps approach and to follow the GitOps approach. And this is the first one is the Terraform. And Terraform, so both of these tools are used by Sitecore inside of the Managed Cloud, and probably that the place where I was faced them first time. But anyway, Terraform uses the declarative approach to deal with the infrastructure management, which means that the user sets an end state of infrastructure, and Terraform performs the actions necessary to set up and maintain the stage, that state. So actually, we define just a final state using some configuration files, and Terraform decide what it should be done and do that actually to desire this state. In opposite, so Ansible is a procedural approach. Use procedural approach where user define steps and to configure and so define the steps, and which is used in a configuration of to achieve the desired state. That means that this is the best suited for adding installations or application changes on top of existing networks. So Ansible is primarily used to provisioning the application itself. So if Terraform is used to provision the infrastructure, so for example, we don't have anything inside of the Azure, and we want to run there some environment, it is easy to use Terraform just to describe the networks, clusters, the size of the clusters, nodes inside of the cluster, and everything which is related to your environment, and perform the deployment with Terraform, and it will be created. And with Ansible, it is primarily used to deploy our custom images inside of the infrastructure that's already created by Terraform. So because you can specify some steps and scripts within the Ansible that will be executed during the deployment. So it is allow you to install something, delete, manage, change, and perform any changes within your application. And for example, in terms of Kubernetes with your cluster. And finally, we got to the definition of Sitecore Managed Cloud, which is just a hosting service that enables customers to deploy the various of Sitecore instances. So it can be XM, XP, even it can be Sitecore Experience Commerce, and we can run it on Microsoft Azure. It is probably alternative to run the Sitecore platform on premise or via any other public cloud. So, but in case of the Sitecore Managed Cloud, Sitecore actively monitors, manages, and maintains both the infrastructure and the application side of your application of your solution. So, um, what I want to mention here that Sitecore Managed Cloud can be built within the Kubernetes, and it also can be built within the PaaS. Both options are available. I was working with the Kubernetes option, and yeah, primarily have the experience with that. And as a agreement of managed cloud, Sitecore provides the pretty high availability SLA, which is almost 100%, and the incident response time is pretty higher. So this is till 60 minutes. That's pretty fast, I think. So Sitecore provides the cloud services like search stacks for your Solr needs. So that's something that we have in agreement within Sitecore Managed Cloud. Okay, and this is the diagram how deployments looks like for the Sitecore Managed Cloud. And of course, the left side is the same. In terms of builds, we have one change here. We still build them using the Docker images. We still use Sitecore base images running and downloaded from the external, from the Sitecore container registry. And finally, we don't push the images to our container registry. We push it's to the container registry hosted by Sitecore. So Sitecore has own Sitecore. So actually create the Sitecore registry for you. When you sign the contract with Sitecore and started using the Sitecore Managed Cloud, you will got the access to the Sitecore or to the Azure subscription within your application, which within the application that already run there. I mean, with Sitecore, which is already run. So everything will be created, resource groups, all services, SQL service, SQL database, Elastic pools. So you will have already search stacks configured. Everything will be ready for your using. And when you want to deploy something custom there, you have to create the custom image on top of the Sitecore's one, push this image to the Sitecore container registry, which is hosted already in the Sitecore's subscription. And then you have a bunch of the pipelines provided by Sitecore in their subscription, of course, that you will run to deploy the application to the managed cloud. So, and of course, that will very similar as it works with your private cluster, let's say, that you set up yourself, but Sitecore uses Ansible to deploy the application, and it is execute some steps with your cluster, and push the latest images that you just uploaded to the container registry to the Kubernetes, actually, to the cluster. So only one difference, that you are not hosting the container registry by your own, and Ansible is used to automate the provisioning part of the deployment. And so now we can see the list of pipelines that are available within the Managed Cloud. You can see that part of them was not used even we was working with project something around the half year. So main of the two main images are the pipelines are the application and infrastructure. Application is used to deploy actually our custom images, and the infrastructure is used. This is the implementation of Terraform, and it used to provisioning the infrastructure. In our case, it means that we, for example, if you want to scale up the number of nodes that can be created in case if it's required, so we can just change the JSON file inside of the repository and push this code to the repository provided by Sitecore and run this pipeline. So there is also some pipelines like reboot node, restart Sitecore deployment. This is something which actually was not used. And so, for example, if you need to upgrade node version, we can run this pipeline, and I think that will be the node will be updated to the latest version. So one more important pipeline is here. Here is front door, which deploys the configuration for our custom host names to the Azure front door. If you need to set up some DNS and to reach your website running within the Managed Cloud, you have to update the configuration for front door. So, and now again, a few slides to a few things to sorry. Again, this goes out. Just want to quickly show you how repositories for application infrastructure looks inside of the Managed Cloud. We have, for example, let's start with the infrastructure. This is the implementation of Terraform again. And probably only one file that you will need to change here is placed inside of the config resources, and file is also called resources. And you can see that it is the configuration for our node. We have actually Windows node with this size, and if you need to scale up with the number of nodes, you just change this number. And to make these changes, you have to create a new branch from the main, make your changes, push, create a new pull request back to the main branch, and once the pull request is merged and accepted, reviewed, and merged back, your changes will be deployed, and you will get your additional number of nodes, for example, available in your infrastructure. Here we can find the front door configuration. We will not look at that in details because this is syntax is related to the Terraform, but that all is definition of your Terraform, and if you need to apply something new, you just have to update code here. And for example, if you need to add new domain or new mapping between domains and backend endpoints, you have just update this configuration. So this is what about the infrastructure, and let's back to the application. So let's go to the application, not back. So here we have a bit more folders, and this is the application. This is the implementation of Ansible scripts, and so we can see that. Okay, let's go from the other side. So there is primarily also only one file that you will change, and it also placed in the config, and then it's in Docker images. And this file is represent the path and the name and the version of images that have to be deployed. So for example, if you want to deploy something new to the CM server, which is run inside of the Sitecore Managed Cloud, you run your build, your custom build that you use, and you can build your custom image in your own. So, and then you push it to the container registry hosted by Sitecore. Then you go to this repository, get latest, create new branch from the main. Then in this new branch, you update the version of this image to the latest one. So you cannot use latest actually. So this sometimes ask me why we cannot use latest. We cannot. I don't know why, but Sitecore saying that it's impossible and doesn't work. And actually it doesn't work because if you just place latest, no changes comes to the server because Ansible does not track that something was changed inside of the Kubernetes, inside of the container registry. So we have to specify the exact version of image that we want to deploy. We change it here, save, create a new pull request back to the main branch. And once the pull request is merged, new image will be deployed to the CM server. This is how we actually work with this repository. And another things that can be changed here, that is roles, Sitecore XM, and here we add something new to our environment if we need it. For example, for the components, we have to add horizon and rendering host to our instances, and we change this. And we have added these folders, added definition of those components. Then we have to update the tasks that will deploy them. But that all is pretty well described within the Sitecore documentation. So everything which is related to the managed cloud have really good documented guides, which really helped us to deploy our application to the managed cloud. So that's probably it because we don't have time anymore. And let me back to my slideshow. Just in conclusion, a few words about the managed cloud. So, and I want to say that there is no exact way which is good or which is not. So we have to measure the advantages of using managed cloud or not to use. It was really good experience. So that was something new. There is, of course, was some difficulties. So, for example, this is the main communication difficulties. You cannot change anything directly on your cluster. You cannot even, for example, when we run Sitecore inside of the Kubernetes, as I saw before, we have to run init images on the environment. So to create indexes and create some databases. And when you just get access to the Sitecore Managed Cloud, you have got this init images already run. But in our case, we have to add new indexes for SXA. We had to add additional packages with again SXA in the horizon, install it to the Sitecore, and when we try to run the init job again, we will just fail it. And we had to create some support ticket for Sitecore, just saying what we have to do because we have to run init images, but it was already run. And finally, they have changed something, and we was able to do that, but it takes some time for the communication, for the changes, and it related to each difficulties that you will face with Managed Cloud. You will have to create a support ticket for Sitecore every time when you need something from some changes on your environment, and that's probably was the main difficult part of this project. So yeah, that was good, and that was a good experience. Thank you for your attention, and probably you have some questions.